Hi everyone and welcome. Let's take a look at problem number 7 from the lesson on polynomial division. So question 7a asks to divide x to the power of 4 plus x cubed y minus xy cubed minus y power 4 by the binomial of the form x squared minus y squared. There are two different ways of dividing these two polynomials, and I'm going to try to go over both of them. First, I'm going to start off by writing the polynomial division, so I need a little bit of space here. And next, I am going to examine each and every term in the polynomial expression, and as you can see, we have two variables present, so the variable x and the variable y. Now, normally, we have divided polynomials where we had only a single variable, and we usually use the variable x, which is very popular, and the rest were just constants. So how do we deal with polynomial expressions that contain a second variable? So the way we want to actually look at this is this. So we focus as one of the variables as our primary variable. So I'm going to say that x to the power 4, so the variable x will be our primary variable. And then we're going to list all the possible terms in this polynomial expression, keeping in mind that for every term, consecutive term, the power of the variable x, which starts with 4, must decrease by 1, so x to the power of 3, and then we have x to the power 2, x to the power 1, and so on. So I'm going to start off by writing x to the power of 4 as my first term. Now, the next term must be an x to the power of 3. Next, we need an x power 2 term. And then we need an x to the power of 1. And last but not least, we have x to the power 0, which is practically a constant. Then we'll work on the next variable, which is y. Now, in the first term, x to the power 4, you don't see y, we don't see y, so we're going to write here y power 0. In the next term, we have y to the power of 1, and that's exactly what we see in here. So we have x power 3, y to the power of 1. Next term, we'll have y to the power of 2, and then y to the power of 3, and the last term will be y to the power of 4. And now, remember that even though we're trying to rewrite the expression, right, with all the terms and list it from highest to lowest degree, you see that not all terms are present in here. We also see some minuses and some terms that are positive, so we have to take care of that as well. So next, what we're going to do is check with every term. So x to the power 4, y to the power 0, right, is our first term, which is basically the term x to the power of 4. So I will rewrite this as x to the 4, and it's a positive term, and that's exactly what we have. So the next term is the x3y term. This is present in our expression, so I'm going to write in here x to the power 3, y to the power of 1. So the next term that I see here in the order, in the polynomial, with all the terms and listed in order from highest to lowest, is x squared y squared term. And as you can see, our expression doesn't have an x squared y squared term, so this will be simply a placeholder, which means that it will have a coefficient of 0. So we're going to write 0x squared y squared. So the next term has to be the xy cubed term, and as you can see, this is present in our expression, and it has a negative sign. So what we're going to do is rewrite this with a negative sign, so this would be negative xy cubed. And lastly, we have minus y to the power of 4, and that would be the exact same term we have here, so we're going to write minus y to the power of 4. So this will be our polynomial expression with all the terms, so power 4, power 3, power 2, power 1, and power 0, and listed from highest to lowest degree. So once you have taken care of the polynomial that we are dividing, or in other words, the dividend, then we're going to take care of the divisor, which is x squared minus y squared. So the divisor x squared minus y squared, again, contains two variables, x and y. And we are going to treat x as our main variable, so this will be our leading term, which we will rewrite as x to the power of 2. You don't see the y, which means that y must be to the power of 0, right? And then the next term must have an x to the power 1, and the last term x to the power of 0. So we need to have all the terms and list it from highest to lowest degree. When we say all the terms, it means that if we have the power 2 term, it means that we're going to need the power 1 term as well, and the power 0. Now, obviously here we have another variable, the variable y, so we're going to make that visible. So y must be power 0 here, y must be power 1 here, and y must be power of 2. So the terms in this expression, listed from highest to lowest degree, treating x as our main variable, would be the x squared y term, the xy, and the xy squared. Now, based on what our divisor looks like, we are going to say that we have the first term x squared. So our x squared y to the power 0, remember y power 0 is basically 1, is this one here. Now the next term in the divisor must be the xy term, and as you notice here, there is no xy term, so we're going to need to use a placeholder for this. You can either write plus 0xy or minus 0xy, doesn't matter. And the last term we need to have is x to the power 0, y to the power 1, which means that, remember, this would be 1, so that would be our y squared term. And what we have in our expression is minus y squared. So what we have done so far is rewrite the dividend, and rewrite the divisor. And actually, I'm going to write that down here. So this will be the dividend. And this is the divisor. So dividend, numerator, the polynomial we're dividing, that means the same thing. And this is the divisor. So now we're ready to divide. So I'm going to use long division, and that is because my divisor is power 2, so I cannot use the synthetic division, since it is applicable only when divisor is linear. And I will rewrite my expression. So what we have in here is x to the power of 4 plus x cubed y plus 0x squared y squared minus xy cubed minus y to the 4, which is divided by x squared plus 0xy minus y squared. And here we go. Draw the line. We'll start dividing. So this will be a normal long division. So again, as always, we are going to compare the first term in the divisor with the first term in the polynomial, and we're going to say that x squared goes into x to the 4. Let's check. Divide x to the 4 by x squared, and we get x to the power of 2. So we're going to say that x squared goes into x to the 4 x squared times. So that will be our first term in the quotient. So we take the x squared and we'll multiply it by the divisor x squared plus 0xy minus y squared. And whatever answer we get will be listed underneath each respective term in here. So x squared times x squared, x to the 4. Next, x squared times 0xy is 0x cubed y. And lastly, we have x squared times negative y squared minus x squared y squared. Subtract this. Draw the line. And we have x to the 4 minus x to the 4, 0. Next, we have x squared y minus x cubed y minus 0x cubed y, 1x cubed y. 0x squared y squared minus negative 1 x squared y squared makes positive x squared y squared. Next, we bring down xy cubed. So that's a negative xy cubed. And again, the same idea applies. So we are trying to now compare or see how many times x squared goes into x cubed y. The way we do it is always the same. So we take the x cubed y, divide by x squared. So x cubed y over x squared equals xy. So we're going to say that x squared goes into x cubed y, xy times. Again, same idea. We take xy and we multiply it by the divisor. X squared, 0xy minus y squared. So that will give xy times x squared, x cubed y. xy times 0xy will give 0 x squared y squared. xy times negative y squared will give negative xy cubed. Draw the line again and subtract. Whatever we obtained here, and here we go again. We have x cubed y minus x cubed y, no x cubed y, so 0. X squared y squared minus 0 x squared y squared is x squared y squared. Negative xy cubed minus negative xy cubed, 0 xy cubed. So we're going to have 0 here. I'm going to bring down the last term in the polynomial. That's negative y cubed. And again, same idea. We are comparing the first term in the divisor with the first term in whatever is left from the polynomial. Right? And we do that in the same way. So we take the first term in the polynomial, what is left in the polynomial, which is x squared y squared, and we see how many times x squared goes into it by dividing it. And it seems that x squared is going to go into x squared y squared, y squared times. So again, same idea. We're going to take y squared and then multiply it by the divisor, which is x squared plus 0xy minus y squared. Here we go. Y squared times x squared will be x squared y squared. Y squared times 0xy is 0xy cubed. And y squared times negative y squared is negative y4. Sorry. Just realized that I dropped down the incorrect power here, so that's a power 4. So remember that this 0 in here is a 0xy cubed, right? So the terms are listed in order here. So we're going to draw the line again, and we will subtract whatever we're left with. And as you can see, we get a remainder of 0 because x squared y squared minus x squared y squared, that's a 0. 0 minus 0, 0. Negative y cubed minus negative y cubed is also 0. And that means that the remainder will be equal to 0. Okay, so we're going to say that the quotient in this case will be qx equals x squared plus xy plus y squared. And if you want to check if whether or not the answer is correct, use the division statement. So multiply these two together, right, and check and see if you obtain the same dividend. So this is one of the methods of dividing this dividend by the divisor when two variables are involved. Now, there is another method of performing this division, and I will briefly explain this, the strategy of it, so that you can try on your own. And for this, I'm going to start off by using an example, a numerical example. So, if we want to, for example, divide 36 by 6, right? So we know that 36 divided by 6 would equal 6. Now, the same answer can be obtained if we divided 36 first by one of the factors of 6. So that would be divided by 2, and that will give us the number 18. And then divide 18 afterwards by 3, and that will give the answer 6 again, so the final answer. So the final answer 6 can be obtained by either dividing by the entire divisor, and that's what we did in this solution, or what we can do is we can divide it one at a time by each factor of the divisor, because 6 has 2 factors, so 2 and 3. Then the division can be performed more slowly by dividing 36 by 2 first, and that's what we did here, and then dividing the answer that we obtained from 36 over 2 by 3, and that's what we did in here, and that would be the next step. So the next strategy is built on this idea, and the way this works is by simply factoring x squared minus y squared into x minus y, x plus y. And what we can do in this case is divide the polynomial by x minus y first. So this polynomial right here by x minus y, and then divide it, which is the first factor, and then divide it afterwards, whatever quotient you obtain, by x plus y. So that would make the division a little bit easier, because dividing by a divisor in binomial form, first degree, is less complicated than a polynomial of a degree higher than 2.